Hello, student meteorologist Michael Jablonski back at it again with the extended forecast. So to quickly recap what we had in the central PA forecast, a slew of showers affecting the Commonwealth with the potential for some flurries coming late on Sunday. Otherwise, you'll see some strong rain showers on Friday, lighter rain showers on Saturday, and maybe nothing at all on Sunday. But I do find it interesting that we have this potential for flurries on late Sunday and even early Monday morning, but by the middle to late portions of next week, temperatures will be going all the way from low 40s to high 50s, so quite a turnaround for Pennsylvania weather, especially a surprise for November, if anything. Could see some potential rain towards the end of next week. That'll be something to keep an eye on, of course, but in the meantime...
When it comes to notable weather in the month of September, hurricanes often take the center stage, but there's a weather phenomenon that is not as well known, derechos. While many people have probably heard of its effects, few know how they occur, how to deal with their dangers, and why they are notoriously unpredictable.
Well, MJ, we're nearing the end of the semester and most students' time at Penn State until next fall. What does it look like weather-wise for these last few busy weeks?
Well, so Alex, I can say that this week's weather has been surprisingly warm and surprisingly stormy as well, but the next few days do appear to be on the mild side by comparison. As for what exactly to expect, I'll be delving into that during my upcoming forecast.
Hello, student meteorologist Michael Jablonski here with the central PA forecast. A slew of showers expected for the Commonwealth with perhaps a surprise in store. But first we go to the expected weather, which is an abundance of precipitation for Friday. You see it affecting the western half of the state early on Friday morning, where the central and eastern parts of the state will start to see rain Friday afternoon and lasting until Friday evening. But as the showers move out of the state on Friday, we'll see more precipitation affecting the state on Saturday, although this will be much lighter than what we'll get on Friday. In fact, the central and southeastern parts of the state may only see a light drizzle, if anything at all, whereas the northern and western parts of the state could not only see some strong rain, but some mixed precipitation if the temperatures get low enough. If you're wondering how this affects the upcoming game between Penn State and Michigan, conditions should actually be perfect when the game starts off at noon. Not too sunny, not too windy, just right for watching what will hopefully be a great football game. Could be some light drizzle towards the end of the game, though, so be on the lookout for that.
When it comes to looking at the past, present, and future of hurricanes, Dr. Anthony Didlake is just the professor to speak with. He specializes in tropical meteorology at Penn State University. Didlake remembers Sandy's occurrence quite well. Hello, and welcome to this week's show of Whether or Not. I am your host, Michael Jablonski, joined by our forecaster for this week's show, Stuart Dougherty. Well, Stuart, temperatures have taken a steep decline from what they were these past few weeks. Will they continue to drop for the Commonwealth?
Hello, student meteorologist Michael Jablonski here with the central PA forecast. Pleasant weather is just around the corner, but before we can get to that, first I have to get through Friday, where you'll see that we have rain consistently throughout the Commonwealth during most of the day on Friday and into Friday evening. You see the hardest hit areas for precipitation being central Pennsylvania, but you will see some rain in the outlying corners of the state as well. For Saturday, we will see rain moving out of the northeast, but humidity from that rainstorm will stay in place. Clear skies should occur towards the later parts of the day, just in time for kickoff for the Penn State game. And for Sunday, we'll see skies stay completely clear here. The humidity will still be in place, but it should be great weather all throughout Pennsylvania. You'll see some rain down to the south in the remnants of Tropical Storm Nicholas, but that shouldn't affect Pennsylvania at all in the upcoming days.
Thunderstorms can present many dangers to humans, but you wouldn't expect a horde of scorpions to be one of them. Yet, this was the case for Aswan, Egypt. Last week, they were one of many places in southern Egypt to experience strong storms. These storms produced 0.04 of an inch of rain, along with hail and strong winds. Now, 0.04 of an inch may not seem like much, but for Aswan, it measures out to be 80% of its average yearly rainfall. As if the local flooding wasn't enough, however, the excessive rain drove out hundreds of scorpions into the city. Many of these scorpions were poisonous, and their stings would send over 400 people in Aswan to the hospital. These unfortunate folks would all go on to be treated with anti-venom doses, however. The thunderstorm in Egypt serves as an example that even the simplest of storms can produce the most unusual of effects. 2021 has been a year of weather outliers for the U.S., and this summer proved to be no exception either. The National Oceanic and Atmospheric Administration confirmed that the average temperature across the contiguous U.S. was 74 degrees, an astounding 2.6 degrees above average. These numbers surpassed the record for the warmest summer in the U.S. ever, which was set all the way back in 1936. Just as the infamous Dust Bowl in the Midwest helped keep conditions extreme back then, constant droughts and subsequent wildfires west of the Rockies were a key part to this year's scorching temperatures. Places such as Portland broke their all-time daily temperatures, reaching triple digits. Minneapolis and Boston also saw an unprecedented number of days where the daily high temperatures were 90 degrees or higher. Despite the above-average temps, however, this summer proved to be one of the top 10 wettest summers in the U.S., with record rainfall in places such as Mississippi, Michigan, and Massachusetts. With seemingly every month bringing new weather extremes this year, one can only wonder how the upcoming winter will play out. In a previous edition of Whether or Not, I talked about a phenomenon which I dubbed as a space hurricane. Fittingly, another phenomenon has recently presented itself as a sequel, space lightning. The lightning in particular is actually referred to as a blue jet and isn't exactly new. Aircraft have observed this phenomenon for years, but the limited ability to record data from the stratosphere has prevented scientists from fully understanding how blue jets occur. Luckily, instruments aboard the International Space Station happen to be in the right place at the right time, and with sufficient data on the matter, scientists have now determined that blue jets are indeed a form of lightning. The lightning bolts travel from the tops of thunderclouds into the stratosphere, spanning 30 miles in a matter of seconds. The blue hue of the bolt is due to an abundance of nitrogen in the stratosphere. More research is being done on blue jets to see the effect they have on radio interference. So however wild the conditions which occur in space are, one can only hope that they stay in space.
2021 has been a chaotic year for weather so far, and that has continued to be the case as we enter the month of April. There are many factors which drive these weather patterns each year, but for this week's feature I want to talk about one in particular, the Gulf Stream. Now for those who are unaware, I'm actually revisiting this topic as I briefly covered it during a Nature in the News story last month. In order to go more in depth this time, I spoke with two professors at Penn State on the subject, Dr. Melissa Gervais, who does some research on changes in oceans and Earth's climate, and Dr. Raymond Najjar, who studies oceanography and coastal waters. Of course, in order to understand the importance of the Gulf Stream, it first helps to know how the Gulf Stream works.
It is a big transporter of heat in the poleward direction.
In general, storms can feed off of gradients in temperature. And by temperature gradients, what I mean is changes in temperature across space. And so the fact that you can go from a really warm Gulf Stream to a really cold continent in the winter, that can enhance the temperature gradient. And so storms can actually use that to feed off of to become stronger.
And both of them carry very warm water poleward. And, that sets up a lot of instability in the atmosphere, particularly in wintertime. And that ends up leading to a lot of cloud formation and precipitation.
Just as the Gulf Stream can influence the atmosphere, it can also be influenced. In particular, I wanted to see what role the ocean, and a process known as AMOC, played in affecting the Gulf Stream.
The Atlantic Meridional Overturning Circulation, or the AMOC, describes the overturning of the ocean circulation. So we have generally northward flowing ocean currents at the surface, and then we have deep water formation in the north, and then we have returning flow that's southward at depth.
What the overturning circulation is kind of a conveyor belt circulation in which you have warm water moving poleward in the Atlantic, and the Gulf Stream is a big contributor to that.
And in particular, the fact that you have this dense water forming in the North Atlantic and how that can help to kind of drive this overturning circulation. Now, that's a very simplified picture. It's actually much more complicated than that.
And indeed, I found in looking into this topic that analyzing and measuring the Gulf Stream is very complex. When I asked both professors about the difficulties of assessing the Gulf Stream, they actually gave pretty similar responses.
It is very challenging for us we have very limited observations time-wise, direct observations of the AMOC.
I think it comes down to the lack of direct measurements over a very long time period.
It's sometimes when you have a short period of time to look at and you know that there's a lot of variability, there's a lot of things that can happen.
The ocean is a very difficult environment to make measurements in. There's a lot of fouling of instrumentation. There's also a lot of variability. It's expensive to take a ship out into the middle of the ocean. So there's a number of reasons why it's very challenging to directly measure ocean currents.
The Gulf Stream may not be talked about frequently, but its importance cannot be understated. In fact, both of the professors I talked to made sure to emphasize how the Gulf Stream could affect Earth's climate in the future.
With regard to tropical cyclones, anything that affects the surface ocean temperature is going to affect tropical cyclones. So, weakening Gulf Stream would not only lead to cooling of the subpolar North Atlantic, but should lead to a warming of the subtropical Atlantic. And that by itself, you could argue would strengthen tropical cyclones.
One aspect of the Gulf Stream that could be really important for weather is the relationship between the Gulf Stream and the storm track. So when it comes to future climate change and changes in the North Atlantic Ocean, this is something I have done some work on. My work in this region has talked about the impact of the warming hole, so this region where it's cooling. And you can kind of think of that as, it's actually, so if you have the Gulf Stream coming north up the East Coast, then it kind of continues along, and there's a North Atlantic current that goes across the North Atlantic. And so there's there's typically a temperature gradient there. And this slowdown of the AMOC results in a relative cooling in the subpolar gyre, which is just north of it, so just south of Greenland. And that can lead to an increase in the temperature gradient, and that can actually modify the storm track and the North Atlantic jet.
The one area I did want to tell you about the importance of the Gulf Stream is that it does affect sea level. So the Gulf Stream, like most ocean currents, and actually like most wind systems in the atmosphere, is the force balance is largely geostrophic. What that means is that, if the Gulf Stream is coming at you like this, right, Coriolis force acting on the Gulf Stream is in this direction, right, to the right of its motion. And it's balanced, if it's a geostrophic current, it's balanced by a pressure gradient force in the opposite direction. And the way you get pressure gradients in the ocean, well, one of the main ways you get them in the ocean is by a tilting sea surface. So if the Gulf Stream is moving like this, the sea surface is actually tilting sort of downward towards the East Coast. And the stronger the current, the stronger the tilt. The sea surface is relatively low along the East Coast, say, compared to other places because of the strength of the Gulf Stream. So if the Gulf Stream weakens, right, if this current weakens, that means this slope is going to decline, and the sea level along the East Coast is going to rise.
More research continues to be done on these topics, but in the meantime, we'll have to wait to see what the Gulf Stream does, as well as 2021's weather. Reporting for Weather or Not, I'm Michael Jablonski.